Okay, I think we'll get started now. Good afternoon, everyone. Thank you for joining us today for the Clinical Trials Methodology course webinar series. Today's webinar is on a tutorial on pilot studies. Before I introduce our presenter, I want to mention that you can use the chat box in the upper right-hand corner if you have a question or comment. And you can also unmute yourself by clicking on the audio icon to the right of your screen. Also, please remember to evaluate the webinar at the end of today's session. So our presenter today is Dr. Lehana Thabane. He is a professor of biostatistics and associate chair of the Department of Health Research Methods, Evidence, and Impact. He's also an associate member of the Departments of Pediatrics and Anesthesia in the Faculty of Health Sciences at McMaster University in Hamilton, Ontario, Canada. He is also the Director of Biostatistics at St. Joseph's Healthcare in Hamilton. And he has co-authored over 600 publications in peer-reviewed journals and has won several teaching and supervision awards, including the CENB Excellence Award in Teaching for 2004 through 2006, the Faculty of Health Sciences Excellence and Graduate Supervision Award for 2012,
recording is on.
And the McMaster. So if everyone can mute yourselves if you are not muted. Also the McMaster's President's Excellence and Graduate Supervision Award for 2016. So he is the clinical trials mentor for the Canadian Institutes of Health Research, and he is also professor extraordinaire in the Faculty of Health Sciences at Stellenbosch University and holds visiting professorships at the University of Cape Town, South Africa, and UNESP in Brazil. So thank you, Dr. Thabane, for presenting today. You can go ahead and share your screen with your slides.
All right, give me 1 second.
Okay.
Now, first I have to share the screen, right? On my right?
Yeah, correct.
Okay, and then I have to, can everybody see that?
Yes, that looks great.
Fantastic. Now, so Joy will monitor the chart. If anybody is having problems, please, you can send a message to Joy using the chat box, and we'll try and see whether she can try and help you with solving your problems. The second thing I would say is this presentation will be made available to you. I will send it to Joy, and she will share it with everyone in the program. All right. So we'll try and cover a few things today. And a lot of these things, you can get a lot of the details from the paper, which I'll introduce in a minute. We'll talk about what really the similarities and differences are in the definitions of what a pilot and a feasibility studies are, what the current practice is in how these issues are handled in the literature. And then we'll talk about what I call the essentials. Why do we do them? How do we assess whether we've been successful? What are the common misconceptions and some frequently asked questions? And then I'll talk about an update in terms of where the practice is at the moment in terms of how we approach pilot and feasibility trials in particular. And we'll end with a take-home. This paper is available online for free because it's Biomed Central. And a lot of what I'm going to share, it's going to be in this paper. And any other papers that I'll reference will also be available to you online somehow. If you do a Google search, everybody now use Google as a noun and as a verb, and you're searching for feasible and pilot. One of the things you'll find is the word feasible has its origin from Latin, and the word pilot has its origin in Greek. And over time, it evolved into perhaps how we use it today, but previously it really meant, both terms meant different things. Now, if you go further to search the word pilot, you'll realize that its use varies by discipline. So just because we use it in a particular context or sentence in health, it doesn't necessarily mean all other disciplines use it the same way. So being aware of the various use of the word pilot in various disciplines is helpful. that really clears up the language when we communicate. But when you look at the Oxford Dictionary, it uses the word pilot the same as an experimental, exploratory, tryout, preliminary, and so on. And it has synonyms such as feasibility, vanguard, dress rehearsal, and pre-study. And if you look at some of the EPI dictionaries, they use the word to mean you're testing methods or procedures on a smaller scale, and you're going to use information to plan something on a larger scale. And the same thing if you go into the dictionary of medical statistics, is you're testing something on the feasibility of methods and procedures, and the goal is simple. If you look at other definitions online, they all seem to have something in common. You're doing a test of something that you plan to do on a larger scale. So even though you're trying different things, whether it's protocols, whether it's any aspects for which you don't have enough information on feasibility, the goal is you're gaining some knowledge or some information which is going to help you to do something on a much larger scale. So what's the current practice of how these issues of pilot studies are approached in practice? You'll often find that the term pilot and feasibility, they're actually used interchangeably. So these studies, therefore, are not reported consistently when the terms are used interchangeably. Various journals actually don't even have policies of how they deal with these things. And we all know that in research, words matter. The issue then becomes, is the word pilot and the word feasibility, do they mean the same thing? And if they do, what it is that they really mean, and if they don't, what's the differences? So many journals don't even have editorial policies of how they handle pilot studies or feasibility studies in general, which is part of the challenge that we're facing. In fact, we've had evidence that some editors have actually forced authors to change their studies into pilot by just adding the word pilot, while in fact they were originally not designed as pilot, nor were they ever designed as feasibilities. And of course, if anybody wants to get published, they comply with whatever the editor is forcing them to do, and that's part of propagating bad practice, which is what we see in the literature. So overall, there's never really clear sense of how well these are reported. In fact, the few reviews that have looked at this issue found that there's too much emphasis on hypothesis testing, which is really never the primary goal of piloting or assessing feasibility. There are no clear feasibility objectives or outcomes, and the analytic plans are never really well described. And there's not even a mention in many of these studies as to whether they're being done to inform the design of future studies. So overall, the message is that the practice is terribly inadequate in terms of how we use the term, whether they mean the same thing or they mean different things, and how we actually go about reporting studies that report results of pilot or feasibility studies. And the editorial policies are all over the place if they ever exist. In many cases, they don't even exist. So why do people really do this type of studies? Many times they do it to assess procedures and methods in terms of whether would these things be feasible in the main study. And the reason is being simple, because if you're going to plan something on a larger scale and invest a lot of resources and energy, you want to make sure that it's something that can be done. And therefore, in many cases, we use pilot or feasibility studies to check whether these things can be done before we go full scale. So this is a study we did where we're checking whether recruitment would be possible. Can we retain patients once they're in the study? Are we able to actually get all the data that we need and any feedback we can get about the intervention, because we're worried as to whether the intervention would be acceptable to the participants in the first place. Now, we did the prospect trial, and here we were also worried about recruitment and whether people would adhere to the protocol, and even worried about contamination overall. And in the virus trial, recruitment was also an issue. Realized that all these are things that could actually kill the study even before it gets started. Many times we know that the number one reason why most trials fail is because of recruitment. and retention in the study, and therefore assessing whether these things would actually work in the main study would be helpful. Now, I just want you to realize that proof of concept is not the same thing as proof of feasibility. Typically, we use the term proof of concept for studies that are trying to assess whether a treatment has a biological effect in patients for whom the intervention is actually indicated. So typically this would use surrogate outcomes, and if you can show that actually the concept works, if I'm trying to actually deal with cardiovascular mortality and prevent it, then I could use blood pressure as a surrogate marker of that. And then you can assess whether would this therapy actually work if I'm trying to prevent cardiovascular mortality. Now, you could show that the concept works, but doesn't necessarily mean that the main study addressing protection of cardiovascular death would actually be feasible. And typically, such studies would tend to require a lot of patients. So proving a concept is not the same thing as proving that a study is feasible. So typically, when we are proving, we're trying to assess whether something is feasible, it means at some point we want to go back and check whether we've been successful or we have failed to show feasibility. And therefore, one of the potential outcomes of such a study is you could actually say, hey, we should stop. We're not going to be able to actually do the main study because the results we have show that it would not be feasible. Or it may actually be feasible, but we may have to change a few things to make it more feasible or more practical. So there's a few things that you need to do. So having some criteria which really are guiding principles to be able to help you to do that, it's helpful. Now, realize that we actually have the criteria for stopping even in the main trial. Typically, we're trying to achieve the minimum clinically important effect, and that's really when we know we'll be successful. In the same way, you need some criteria a priori to be able to assess whether your feasibility assessment has been successful. Now, if you look at the literature, many of the studies really tend to neglect this aspect, and therefore it makes it even harder to interpret the results in terms of feasibility. How do we know that this were objectively done? This is one of the examples of the trials we did. We said, well, we would actually declare this feasible if we can achieve over 80% compliance to this assessment tool. So we had a priori criteria for determining feasibility. The same thing in the VITALS trial, we had criteria for assessing success on different aspects of what we are assessing for feasibility. And in this trial, this was done by some of my colleagues at McMaster, led by Deborah Cook and Donnie Arnold, and they had criteria for assessing whether it would be feasible to actually move on to the main trial. Unfortunately, there's a lot of misconceptions about pilot or feasibility studies or trials in general. And one of the misconceptions is that is the study that can be completed very quickly. And we all know that that's not really what defines a pilot or feasibility. So you often have trainees given these studies by their mentors or supervisors, and they often will call them, you go do a pilot, and typically they don't do a good job because they think a small study defines a pilot. A study that does not require funding, and we've had excuses such as, I don't have any funding to do a big study, or my boss told me to do this one, and they call it a pilot because of those reasons. A small study that has limited funding, we've had excuses such, I have funding for only 10 patients, or for a limited seed funding, and therefore I will call it a pilot or a feasibility study. So these are some of the misconceptions that I've come across. A single center study, I don't have the resources for a multi-center study. So-and-so did a similar study, and they got statistical significance. Ours uses 12 patients, which is double the size, and therefore we'll still call it a pilot. We did a similar study before and got it published. Typically, these are unfortunate excuses which are really mischaracterizing what a pilot or a feasibility study is. Bear in mind that really it derives its name from the goal of assessing feasibility. So what are the questions that people often ask about them? People will often say, can I publish the results of a pilot? Many journals don't like pilot studies and so on. And typically I often respond by saying, yes, we actually should publish the results of every research that we do. The reason why it's important is because it provides information about feasibility. And we can help the research community from learning from our own efforts when we assess feasibility, so we can avoid duplication of efforts. And actually, one would argue that we have the ethical and moral obligation to do so. If we are going to invite patients to be part of a study, whether we call it feasibility or not, it is essential that we then share what we've learned from that. And the primary goal of feasibility studies or trials is really to learn about feasibility of large studies, and this is equally essential to patients. Now, many of them are not designed to show statistical significance and therefore should not be reported with emphasis on statistical significance, but rather the emphasis should be on feasibility, which is the primary focus. Now, can you combine data from a pilot with the data from the main study? My answer is often yes, you can, provided the methodology of the pilot and the main study is similar. And there are cases where we've had no drastic changes between the methods that were used in the pilot, even though we're assessing whether the methods would be feasible in the main study, and therefore you could combine the data to make full use of all that you have. Now, can I combine the results of a pilot with results from another study or in a meta-analysis? The answer is say yes, you could do the same. In fact, when you look at many of the systematic reviews and meta-analysis, quite often you'll find they include results from pilot studies. You are really trying to use all available information or knowledge, regardless of the design of study, to be able to see what the collective wisdom is. It also depends on whether the results of the main study have actually been reported, because that would even be better than using a pilot. Now, can a pilot exist on its own? The answer is yes, it can, if we actually show that it is not feasible to do the main study, or we simply don't have the money to do the main study. This can happen, but if you share the results of piloting, then whoever has the resources can learn something from there, and they don't have to actually perhaps duplicate some of the things you already have information on. Can you apply for funding for a pilot study? The answer is yes, of course. But it needs to be justified in the context of the main study and the reasons why you need to start with a pilot in the first place. So it is not useful to actually present the pilot without linking it to the main study in terms of what is the overall goal and the long-term goal, and what it is about that main study that we are uncertain about, for which we need to design a pilot to provide more information on. Can I randomize patients in a pilot? The answer is yes. Some of the pilot trials, the main reason why you may actually be doing a pilot is to see whether randomization would be feasible. Would it be acceptable to people to want to participate knowing that they might actually be randomized to placebo, as an example? Now, can I use this as a pilot to estimate the sample size for the main trial? The answer is yes, you can. In fact, in some cases, pilot trials or studies have been used to provide information that could be used to estimate the sample size for the main study, simply because there may be nothing in the literature. However, I often encourage people, and strongly encourage people, to use a sample size table in which they actually acknowledge the uncertainty inherent with in the information from the pilot. So instead of calculating a single value for the sample size, you could actually calculate a table acknowledging that the information from a pilot is very uncertain and very imprecise, and therefore you're trying to get a sense of how the sample size would vary if you varied the estimates, and you can use the confidence interval of the estimate from the pilot to do this. Now, can I use the results of a pilot to treat my own patients? The answer is not a good idea. Remember, they are designed primarily to assess feasibility, not to provide definitive information about how to treat patients. In fact, one would argue that it's often dangerous to actually rely on a single study to determine how to proceed in care, we rely on collective wisdom from various studies that have replicated each other to be able to see how to best take care of patients. Now, what can I do with a failed or a bad pilot? I often say there's nothing that is completely useless. You can always use it as a bad example. So even when you're training others, we often learn from mistakes, and we can learn from mistakes of others about what not to do or how to do things better. Now, should they be registered? I say definitely yes, especially if they're interventional studies, because you're going to have a challenge trying to publish it if it's not registered. Pretty much all journals now have signed on making sure that they would only publish studies that have been registered for interventional studies. So what is new in how the practice is being initiated? So a few of us, we decided to actually see whether we could change the practice in how pilot studies are designed and reported overall. So we decided to actually start small. We're focusing on pilot studies that are randomized and are primarily designed to actually inform the design of the main trial. So we came together with colleagues from the UK to see whether we could actually change the landscape in terms of how these things are done. I have to admit that if I take you back a little bit, now remember that the way the concept came about was really after the birth of what now came to be known as evidence-based medicine. And as people were trying to get into this, now you realize that evidence-based medicine, they then began to actually focus on systematic reviews and meta-analysis of randomized controlled trials. And they realized that, well, the best way to really do this is to really synthesize this evidence to be able to help people make better decisions for the patients, for the care of their patients. So remember that you have the systematic review at the top of that hierarchy of evidence-based medicine, and systematic reviews of well-appraised randomized controlled trials. So the Cochrane collaboration was born in 1993. This was really led by Ian Chalmers with people like Dave Sackett from McMaster when they did this. And this was really named after Archie Cochrane, who had been recommending and suggesting to people that really the best way to make decisions is to rely on collective wisdom from all the research that has been done on a topic. But when this began, they realized that unfortunately a lot of these trials were not consistently reported. So if you have all the evidence from various studies, but unfortunately this evidence is not reported consistently, it makes it a lot harder to really get collective wisdom from these trials. So as a result of this, Doug Altman from Oxford then decided, why don't we come up with a way of what would recommend for people to report in randomized controlled trials, so that whatever is reported is done in such a way that it will make it easier for us to synthesize that evidence to inform evidence-based decisions. So the concept statement was born in 1996, and the goal was very simple, to be able to really make it easier for people to synthesize evidence from randomized controlled trials to facilitate evidence-based medicine. And since then, the concept has been extended to various aspects. It has been extended to different types of designs, different types of interventions, and different types of data. We decided on starting with this, extending it to pilot and feasibility trials. And when we started, we had a very, large landscape. We could start with, pilot studies or feasibility studies for non-randomized studies. Some are randomized. So we really had a wide spectrum, and we were advised when we had the consensus meeting that perhaps it's best to narrow it down to just randomized controlled trials. So our conceptual framework then was narrowed down. Instead of actually having it linear, rather, we should make it more cyclic, which is really how the research happens, but focus more on the one for randomized controlled trials. So our framework changed to say, when you have uncertainty about the main studies, you could do small non-randomized studies to actually assess other aspects of feasibility where randomization may not actually be necessary. Or you can actually then do a smaller part, which is randomized, which really mimics what the main study will look like. Or you could do what we call an internal pilot, where you're trying to assess something at the beginning, but those patients still become part of the main trial. So the concept, our framework actually changed. And as a result of this conceptual thinking, we then went around to different stakeholders and say, how would one therefore define what a feasibility study is and what a pilot study is? So within this conceptual framework, we realized that all the works that you do in assessing feasibility could actually be called feasibility studies. Some of them would be randomized, some of them may not be randomized. However, if you do assessment of feasibility on a smaller scale using exactly the same design as the main study, that would be called a pilot. And there seemed to be consensus from different stakeholders when we went to various professional meetings trying to gauge people's opinion on this. We therefore then published what we call the definitions paper, trying to define the conceptual framework and providing examples of what really a feasibility study is and what a pilot study is. And within this conceptual framework, not all pilot studies, not all feasibility studies would be pilot, but all pilot studies are feasibility studies in that they are still looking at feasibility. And a pilot would be a miniature version of the main trial in the sense that it would have exactly the same design as the main trial. But not all feasibility studies really need to follow the same kind of design as the main. And fortunately, people paid attention to this paper, and it's really one of the highly downloaded papers from the journal. So clearly, we're dealing with an issue that has brought a lot of challenge for many researchers around the globe. We then published the processes that we had undertaken when we started the job, which was in 2011, and it took us quite a while. You can see that this paper came out in 2016, but we had gone through a lot of process trying to develop this guideline. The guideline itself was also published in 2016 in BMJ, and we also published in Pilot and Feasibility Studies at the same time, and I'll come back to that journal in a minute. So this checklist focused primarily on feasibility randomized control trials or randomized control feasibility trials. And it does not apply to internal trial pilots, nor does it apply to non-randomized studies. So what we did is we did four things. We provide the consort items, and then next to it, we provide the extension to pilot side by side. And within the checklist, we identify items that remain the same. We identify some items that had been modified to be specific to pilot trials. And then we also identify new items that are added to that checklist because they only apply to pilot trials. And then there were some items that were in the original checklist, but we are seeing they are not applicable to pilot trials. For instance, here's the checklist. This is what it looks like. In the first column, you have the original checklist, and then you have the extension to pilot trials. And if you look at the first item, we have modified it to include the word pilot or feasibility randomized control trial. And then if you look at these two items, if we don't actually include the items because the same item that was in the original checklist would also apply to pilot trials. If it's a new item, I'm just highlighting it in green, that means it's a new item that was actually identified for pilot trials. And the reason we did this is because you will see later on that in many cases, as we are trying to assess feasibility of recruitment, we need to know the screening logs to be able to determine recruitment rates and so on. And this is really another new item that was not included in the original, but we think it's applicable to pilot trials. And this specifies the criteria for assessing the success of feasibility to move on to the main trial. This is another item which in the original say, it says, how the sample size was determined. In this case, we say provide the rationale, justification for the sample size for the trial. This, in many cases, may or may not involve calculations for the sample size. But there's various ways. What's important is some rationale or justification needs to be provided. And here's another item which we said this is not applicable. This is about doing subgroup analysis in a trial. And because really in the pilot trial, you're not focused on statistical significance or trying to look at effect modifiers. So this issue of additional subgroup analysis may not be applicable. And here's another one of trying to express effects using different scales and so on. We thought this is not actually applicable because the primary focus is not really to estimate effects as such, but rather to assess feasibility. Now, we said if relevant, report any important unintended consequences. Typically, because you're assessing things for feasibility, there could very well be lots of other things you didn't anticipate, and therefore those would be essential in planning the main study. And we encourage people to actually report them, particularly for a pilot trial. Implications for progression from the pilot to the future definitive trial. This is a new item which we also encourage people to do, simply because that's where the lessons learned become important. Now, remember that people don't typically think of pilot or feasibility trials as important, and in many cases we've seen situations where people don't even pay attention when it comes to the ethics. So we think it's essential for us to highlight the importance of really paying attention to the ethical aspects of doing a pilot or a feasibility trial, and we've added it as a new item in the checklist. What else did we do? We also provide an explanation and elaboration on why each item is important, and we provide examples of best practices to guide people through. So in this particular case, we'll provide an example of best practices of specifying objectives for feasibility, and then we'll provide an explanation of why clear definition or clear specification of feasibility objectives is important. We do the same thing for criteria for judging whether to proceed or not proceed. There's other papers we've seen in the literature. I showed you some earlier examples where people have actually done it, and we therefore provide examples of best practices, and then we provide an explanation of why this is actually essential. Now, the third thing we do is suggest some changes on the consort flow diagram because we thought there's a lot of feasibility objectives, which is the primary focus, that may not lend themselves easily to actually reporting things by group. Therefore, we recommend a different checklist where you are actually reporting estimates by objective, not necessarily by group. So here you're focusing on feasibility things where when you're expressing the estimates for feasibility, it may not necessarily have to be done by a group as is done in the main trial. So screening for eligibility, remember earlier on I said that this is another item which we encourage people to report. It's really at the top of that thing because it could be useful. And later on when you express the estimates, they would go by objective. And many of these objectives may not necessarily have anything to do with comparing between different groups. We then provide the consort extension for abstracts specific to pilot and feasibility trials. You'll recall that the consort has already been extended to reporting of abstracts for trials. We thought it's essential for us to say, if somebody only had access to an abstract, what should that abstract have? And therefore, we show examples of a published abstract of a pilot trial, what would be missing based on that checklist, and how one could actually modify that abstract to make sure that it includes all items necessary for an abstract of a pilot trial. So all these things are really in the E&E document. There's already been a few editorials introducing the statement to various journals, and if anybody is interested in actually doing the same for their own field, I strongly would encourage you to actually do the same. Greg was one of our colleagues who was at the consensus meeting, and he was interested in doing this for the Journal of Clinical Epidemiology. And you can look at his editorial, which I think does a good job. So what's the key message? Really doing piloting is essential because that's where we get an opportunity to assess feasibility. And this is really the best way of assessing whether we would be successful in doing the main study. And we're really trying to explore things that you're uncertain about before you embark on a larger scale. They should be well designed with very clear feasibility objectives, with a very clear rationale as to why there needs to be piloting or assessment of feasibility before you go to the main study. In other words, they need to really be presented in the context of what is it that we are uncertain about regarding the implementation of the main study. They need to have clear analytic plans and criteria for assessing success of feasibility. If we are to use information for sample size calculation for the main trial, we need to acknowledge the imprecise nature of that information by doing a sample size table rather. They certainly need to be registered, and they need to be approached with the same rigor in terms of getting them out into the literature and for the public to see. Remember that really a pilot is not a small single center study. It is not a small study similar to somebody else's study, and it's certainly not a study intended to demonstrate the effectiveness of an intervention, because that's really not the primary focus. Now, people who know where Ghana is, somewhere in West Africa, there's a proverb from the Ashanti people who says, you never test the depth of a river with both feet. And the reason is simple. If you did that, you would actually drown. So you can think of a pilot really as a way for us to test the water, see how deep the river is, and which parts of that river would be easy to cross to get to the other side, so that we don't drown all the resources for the main study. So as we're doing this effort of trying to provide guidance of how to report trials, we then had comments of people saying a lot of journals, they still don't want to change their practices and so on. We decided to then launch a journal that will provide a forum for people to report works on feasibility on piloting, and worked with Biomed Central to do this. And we launched the journal in 2015. So Jill and I, Jill is now at Kiel, have been the editors-in-chief for the journal. And we've really provided invitation for people to really try to share as much works as possible in really publishing their pilot works. Just as an aside, I would say we are actually overwhelmed with submissions to the journal. And if anybody is available and willing to help, this is the time when I can add a bit of commercial to say we are open for business. Please join us as reviewers or as associate editors for the journal. I'll be happy to chat with you afterwards. We then created a website, to provide more information on the journal. We've just actually been going through refining the website in terms of the information, and we try to provide it really as a forum for all information about pilot or feasibility studies, not necessarily just for randomized controlled trials. We are currently working on extending the work to non-RCT pilot or feasibility studies. We are also seeing people now publishing protocols for these feasibility studies, and we are working on how to guide the reporting of such protocols in the literature as well, as a way to tell people really how to best design their studies and so on. So with this, I will say thank you, and we are open for questions and comments. And Joy, please go ahead.
Thank you very much. Are there any questions or comments from anyone? Anyone? There must be somebody. There's 80 people here.
Whoops, I was talking and I was still on mute. Sorry,
Okay.
Dr. Thabane, it's Will Moyer from the University of Michigan. Thank you. We have a few things popping into the chat window. But first, I think I want to ask in general, a lot of people in academia are in a position where they may, I know that a lot of it was like, this is the study we do when we don't have money. And I do recognize that a lot of our listeners are from the US, which has a different funding model for research than Canada and the UK. I guess from the perspective of some of doing the initial trial, sometimes it does have to be done with limited resources, but a lot of times showing feasibility in and of itself is perhaps not enough, and I guess generating excitement and preliminary data that would encourage funders or others to invest further is a potential goal. Now, I guess my sort of more direct question from that is, how does that flow along the continuum? Because sometimes there needs to be a middle phase study that there's a pilot study and maybe like a later phase 2 study that would go on before the definitive phase 3. I guess, how do you put those things in perspective with this as a pathway? And then it looks like we have a bunch of questions in the chat.
All right. Okay. So thanks, Will. I mean, a few years ago, actually, even the Canadian funding agency, the CIHR, did not really invest in supporting pilot trials. I'm using the word trials because that's the area where I have been working, and I was part of the CIHR, rethinking of their funding model for trials. But we were able to actually convince them that if we have researchers convincing us that the area needs work, there's a gap in the literature, we don't know what to do, the burden of this problem is huge in society, and there's indication that there's promising interventions that could actually work because they've been shown to work in other settings. However, we don't know whether we would be successful in doing similar trials in a Canadian setting to actually make this work. And we provide convincing evidence about the importance of the clinical area, the clinical question, and then convincing evidence of uncertainty about getting it successful. We were able to argue that it is in everybody's best interest, both the funders, the patients, and the researchers, to be sure that such a study would be feasible. And therefore, spending resources on supporting feasibility trials was essential. And I think with that argument, the CIHR was actually able to change their attitude and then said, actually, this makes sense. We need to invest in making sure that all the trials we invest on, which now is more money, because trials have become extremely expensive, we need to make sure that they're actually feasible. And the only way for them to be done properly, designed well, with people paying attention, they need to be funded, because they could see the argument that if they're not funded, people don't do a good job. Not because they don't actually want to do a good job, because they don't have the resources to do a good job. So they get misleading information about what would be feasible, which is usually why most trials end up failing, because people had been too optimistic. So I think, the US could benefit from researchers making an exerted effort about the importance of really providing support so that people do good feasibility work, which would benefit everybody. So I would still argue that it is not hopeless to change the landscape. The UK, they were able to actually change that landscape. We were able to change in Canada, and I think we've had collaborations with colleagues from Australia where we've had pilot studies funded by the Australian government. So it is possible for this to happen, but it's certainly not going to happen without every one of us making exerted effort to make it happen. I don't know if this helps well, but I would say it's all in our best interest to keep pushing to change the culture.
That's, that's a really, I think that's a really excellent point. It's something that's noted at Trans NIH in the United States regarding the number of trials that don't recruit at targets, the number of trials that don't recruit at all. So again, I don't expect necessarily the trainees in my course to change the world in terms of changing how funding opportunities are issued, but I think the global insight of investing in the early phase trials and making sure they're rigorous, and again, I think that's something we can work to change the culture on. I think I'll try to kind of synthesize these questions from the chat room, and again, we'll see if we can try to get all of them. I know some of us have another small group session we have that's starting right at 1. One question from Dr. Hawk is that you said on one slide that you should not use the consort guidelines for internal trials. Could you expound on why?
So this statement is an extension of the consort that was designed for parallel group designs for the main trial. And typically for an internal pilot, it's a phase within the main trial. Okay, let me just step back a bit. So what's an internal pilot?
Yeah.
You're doing the main trial, and then there's something about the main trial that you say, we're not very sure about this aspect of the design. Maybe for the first 100 patients of the trial, we should collect this information and then go back and see whether we can refine the design. And the goal is simple. We don't unblind anybody when we do that, and these patients are retained in the main trial and so on. So typically, even when people provide reporting of that internal phase, it wouldn't be on outcomes. It will simply be on a small aspect that they were uncertain about. So typically, the internal is really a phase that's intended to be part of the main study, and therefore the patients would also be included in the main study with the reporting done as though they're just one single group. This extension was deliberately intended for standalone pilot trials where in the end we then report everything, including information on secondary clinical outcomes, which is why we say it's not applicable to internal pilots, because those would usually be combined with the remaining patients in the main study to be done at the end, and therefore the main consort statement would be applicable.
Yeah, and I think just to build upon your answer slightly, I think to give maybe some motivational advice, it may be logical to use the consort extension for pilot and feasibility trials as a guideline for some of the questions you might want to answer in terms of the internal pilot, but assuming the internal pilot leads to the continuation to the larger part of the trial, the overall package would be reported within the framework of the main consort statement. Is that a good representation?
Absolutely, absolutely.
Great. So the next question was, how might you incorporate biomarker studies in this space, or studies that you did mention? I do sometimes say that the most important surrogate outcome that we have is blood pressure on cardiovascular mortality, or at least the one that's perhaps best understood. How about biomarker studies? What do you see how do you see pilot and feasibility studies in that space? I know that's a very broad question.
Well, it's a broad question because you would actually apply to many other things. But bear in mind that when we use the word biomarker, we tend to think of them as really things that have the potential to be used as surrogate markers of clinical outcomes. And therefore, they are typically used in proof of concept studies, not necessarily for assessing feasibility. However, you could say, hey, there's certain biomarkers that we think are important, and we're going to spend resources in capturing this information in the main study. We want to be able to see whether with all the tools and the technologies that we have, can we actually measure them? Many of the biomarkers are made based on blood work. Can we get the blood work? Can we get the blood work transferred from centers to the place where they're going to be processed? What issues come up and so on. So you can still find information about process issues related to how information is captured on those biomarkers. Now, can I get a sense about whether intervention is having some effect on those biomarkers? The answer is yes, of course, you can. Same ways as you would on other clinical outcomes. You can still get preliminary estimates of differences between groups on biomarkers as you would on any outcome. So we would often think of outcomes such as biomarkers or clinical as secondary outcomes in a feasibility trial.
I think that also may kind of address Dr. Narayan's question as well in terms of having potentially efficacy outcomes as secondary outcomes. I think that, I guess one of the things that I think is a area of challenge in that space is, you're setting your quantitative goals beforehand for the trial mainly, but you know that you're mainly powered on the feasibility goal. Can I get 70% of people to adhere to the protocol and those things? What is the best, I guess, reporting and analytic strategy for those clearly underpowered efficacy endpoints that you may have mixed in there? How do you present those in such a way that that these are estimates with very big instability, but there may be some motivation there, and if they show something that's totally crazy, that might be something that you have to address or consider.
And I mean, that's a very good point, because that's really the one area where perhaps the reporting of pilot works have been unfortunately dealt with, because people then start focusing on the significance of those differences between groups on those things, and then when they pick the one that's highly significant, that becomes the main message of the story. Right. So really the key is we don't even encourage people to do tests of significance on anything secondary in a pilot, but rather you present an estimate with a confidence interval and just leave it there, because we're very much aware that unless you have an appropriately powered study, any test of significance that you do, even if it's the main trial, you can never be sure that it wasn't actually a significance that came out of random error. The only way to guard against that is to actually do an appropriate power calculation, so that if you do it, you know that you have ruled out the possibility of this occurring by random error. And if you don't see it, it's not because you're underpowered. It's because it's not there. So in order to avoid the results being misinterpreted as lack of power or as significant, we don't even encourage people to do significance testing. So the guideline right now says stay away from performing tests of significance on secondary, whether it's biomarker, surrogate, or clinical outcomes in a pilot trials. Just to express estimates using confidence intervals.
Yeah, and I think that gets at Dr. Narayan's question. And I think Ram, that it's not necessarily not advisable to include efficacy outcomes observed, particularly for serious diseases where mortality may be expected, but to not do hypothesis tests, but just to present the raw data so people can understand. If this is a large vessel stroke study, and you observed that 20% of the patients die, at 90 days, people would say, okay, that's about the same as the larger NINDS TPA study. So they would have a sense that your population was properly specified and recruited. If you had 1% mortality, they would know that there was something different about that population. But you wouldn't necessarily do a statistical test to say, 20% is different than 1%. You would just say, we observe 1%, and you have to think about that in light of the external information about the disease. Is that a fair representation?
It is absolutely true. Now, bear in mind that we now know that even in main trials, all those studies that are stopped early, for whatever reason, that we tend to get misleading information about efficacy, because earlier on during the trial, we either have, you know, too good to be true type of results or too bad to be true type of result. So, right. Think of a pilot, it's already small by definition, and you're more likely to see extremes which may actually be misleading, which is why staying away from things that may tell you that, hey, something good is happening here or something terribly bad is happening. The best thing is just present the information, but people will read that as a signal in relation to what they've read in other studies, understanding that the primary focus is really not to test for significance on these outcomes, but rather to assess feasibility with some indication whether what you're observing on outcomes may be consistent with what you might want to do in the main trial or hope to see in the main trial.
I think we have probably time for two questions, which I think are relatively quick. One is, are you aware of a good, reliable textbook that supplements the articles, or would you? And I tried to go to the website that you showed, and it looks like you guys haven't quite launched it yet because it asked me for a username and password. I mean, some things in science are moving at too sort of fast a pace in terms of innovation to really print textbooks, and I know that with the launch of the journal and some of the really highly cited articles you've had in the design, it may not be that there is a good textbook that you could recommend at this point. But is there anything that you could think of that would help people who are in the design phase for studies in this space?
I mean, it takes forever for innovations to get into textbooks. Unfortunately, we're still at the early phases of changing the culture about how people approach this type of studies and designs. So for now, I think we just have to rely on articles, which is really why we're trying to launch the website. Unfortunately, you're right. We still haven't launched it. We got the prototype about a month ago. I thought it would be out by then, but it looks like we're still working on launching it. So this is really the place where we think everybody might be able to get what we have so far on the topic.
So I think on a final question that I think this comes up with for a lot of people, and this is from Dr. Patel at the University of North Carolina, how do we determine the size of a feasibility study looking at recruitment or intervention compliance? I think that is a great question.
That's a fantastic question, yeah. Because remember the way we do it in the main trial, we say, all right, we want to be able to detect this minimal clinically important difference and do it in such a way that we have a very high probability of detecting it if it exists. And that's really our criteria for success. That's minimum clinically important difference. Now, bear in mind that if I have the same criteria for success if I say I want recruitment in this pilot to be at least 80%, that's my recruitment rate. So it means if I were to actually estimate the recruitment with a 95% confidence interval, I want that 95% confidence interval to have a lower bound of 80%. So I can then use that to actually estimate the sample size. Right? Now, there's a bit of an unfortunate situation with this. In the paper, we have an example that's doing exactly that. But for some reason, the number that's in that paper is wrong. And I've been running after the journal to actually correct that number. So I get a lot of emails of people who say, we understand the concept of how to do this, but the number that we're getting is not the same as the one in the paper. We're getting 289. The number in the paper should be 289. I don't even know how the other number got in there. But really, you want it such that your lower bound of that estimate really is the criteria for your success. So you want that amount of information. And it makes sense to do that because you're basing it on the objective, you're basing it on the outcome of interest, which is a feasibility outcome, and you're using it on your criteria for success. Right? So there has been a lot of recommendations from various schools of thought about, 30 patients for individuals. They're all ad hoc. I often say, really, when you think about it, the primary question drives the design. And if the primary question is feasibility, then the issue then becomes, when are we going to declare feasibility? How much information do we need to be able to comfortably declare feasibility with high confidence? That's really how you do the sample size calculation.
All right. Well, at this point, I am going to have to drop off to go over to another small group. I think Joy has put up the link for the webinar evaluation, and I think if you have additional questions, I think you can email Dr. Thabane, and we really, really thank you for on short notice coming in to help our trainees, as a lot of us were having a lot of questions, and it was just such a pleasure to have you as one of the preeminent leaders in this area come and speak with us a bit about the great work you've been doing. So really excited to learn from this, and again, we thank you from the bottom of our hearts for making time for us today.
You're welcome, Will, and thank you for inviting me to be part of the discussion. And I certainly would be happy to answer any questions that people would have as they continue to dig deeper into the area. I will provide the materials to Joy, and Joy can share the presentation with everyone.
All right. Thank you. And again, this has just been a pleasure.